problem here because we don't know any of the constants. One of the coefficients has a pretty strong property. We have n that has a prime signature of 6,4. Now what this means is that if you take two, I don't know if they have to be distinct primes or not actually, but anyway, if that would say that n would look like this: p raised to the 6th times q raised to the 4th, where p and q are of course primes. And I don't think they have to be distinct, but I don't know if it's really that important actually. But in any event, maybe it is. But anyway, I'm not so sure about that. But in any event, also this could be 4 and this could be 6, the way this set notation is set up. Okay, so n has this property that it's p raised to the 6th power times q raised to the 4th power, where p and q are primes. All right, and we're supposed to answer the question: how many integers m would result in this quadratic having only integer solutions? Okay, it's kind of fascinating to me that you can get somewhere with this. Now, one property that's very, very important is that the number of divisors of n, the number of positive divisors of n, I should say, is equal to 7, which is 6 plus 1, times 5, which is 4 plus 1. That's equal to 35. And again, folks, let me write down positive divisors. And I'll just write the name of brevity here, positive divisors or factors. Y'all remember, if you have 35 positive divisors, you have 70 total divisors, because each one of the positive divisors can also be negative. So that would be 70 total divisors. And y'all, a simple example is just to think of 6. 6 has 4 divisors, and I mean 1, 2, and 3, right? And 6. But that also minus 1, minus 2, minus 3, and minus 6 are divisors of 6. Okay? So that's a little twist that is important as far as solving this problem. Divisors. Do I have room to spell it here? Divisors. Okay? So the 70 total divisors is what's going on for this particular n. 70 total divisors. Half of them are positive, half of them are negative. All right? Now, so let's move along. Now you can rewrite this in a way that's a lot more palatable. You can divide through by m, and you get this statement right here. Again, it's in quadratic form, and we have n over m as the coefficient of x. Now, if we take R1 and R2 to be integer roots, and that's what this is saying, integer solutions, integer roots mean the same thing. Roots, solutions mean the same thing in this context. We see that n over m is equal to minus R1 plus R2, right? It's minus the sum of the roots, but this object has to be an integer. It's known that n has 70 total divisors, right? Because it's one of these, it has this prime signature. N has 70 total divisors, right? So if n has 70 total divisors, that means that m is equal to 70. Pretty nice, I think. Okay, m equals 70. Was that the question? Yeah. How many integers m? Okay, so there's actually not saying m equals 70 is dubious. There are 70. Let me erase this. Okay. In fact, it's just wrong, right? There are 70 such m. Right, folks, and that makes sense because, again, n has 70 total divisors, half of them negative, half of them positive. All right, n does. N has 70 total divisors. So let m be any one of those 70 divisors, and this will resolve to an integer, right? For each one of these m, n over m is certainly an integer, right? n over m would be an integer. That's clear, just by the definition of divisibility, right? So this is the answer, ladies and gentlemen. 70 such m. And it's intriguing because you can, it's absolutely any integer of this form is what we mean by the so-called signature. For example, the smallest one would be probably n is equal to 2 to the 6th times 3 to the 4th, whatever that's equal to. Okay. You would put, 2 to the 6th times 3 to the 4th, put the 6 with the smallest prime. And that, again, this doesn't mean the 6 necessarily goes with the smallest prime. But that number is too big to say. I don't know what it is. But if you put that number in here and went to the trouble to count the solutions, you would see there was exactly 70. Okay, and so I think that takes care of business, folks. We are done. This is the answer. Thank you for viewing.